Sir, we are not able to hear you, sir.
Guys, am I audible? Those who are online, I'm really
Yes,
sorry.
sir.
Yes, sir.
Yes, sir. Now only, sir.
I'm sorry, I thought it was logged in. Extremely sorry, I did 2 problems, okay? Yeah. So can you tell me what is the answer for this? Show that the signum function f map from R to R given by f of x is equal to 1 if x is greater than 0, 0 if x is equal to 0, 1 if x is less than 0 is neither 1, 1 nor onto. See, signum function's definition is already given here. It's a many to one function. Why? Because when you substitute any positive value of x, right? When you substitute any positive value of x, the answer is always going to be 1, right? X is equal to 0, it is 0. When you substitute any negative value of x, the value is going to be 1. Actually, it should be minus 1. There's a mistake. So the graph for this will look like this. So here, where will be the point of discontinuity? Look at it, no, you will be able to see at 0. So here it will be an open circle, here it will be an open circle. So this function is neither, okay, it's not 1, 1. I hope that is clear because it's many to 1. What about onto? So you see the codomain set, you have real numbers, but what is the range set? Minus 1, 0, and 1, right? Except those 3 elements, the other elements do not have a pre-image associated. So this place you need to put a big dot like this. Means this value is actually the function value. Because x is equal to 0, what is the function value? 0. Clear? Shall I proceed? No. A is equal to 1, 2, 3, B is equal to 4, 5, 6, 7. Let f is equal to 1, 4, 2, 5, 3, 6 be a function from A to B. Show that f is 1, 1. Is it 1, 1? Because no two elements in the range set are the same. Right? Hence, it's a 1, 1 function. Then what about, oh, we have to show that f is 1, 1. How will you show? That's the same logic. No, since each element is associated with a unique output, it's a 1, 1 function. 1 minute. So check the solution. So that's the thing they have given. Each input has a distinct output. Right? You're copying it. Huh? You're reading it. Okay. Are you clear with this? Yeah. So it is seen that the images of distinct elements of A under F are distinct. That is the reason. Hence it's 1, 1. Simple. Okay. There is nothing much to prove. What about the 7th one? In each of the following cases, state whether the function is 1, 1, onto, or biject. First one is bijective. Okay. So how to do that? You will say f of x1 is equal to f of x2. So 3 minus 4x1 is equal to 3 minus 4x2. 3 and 3 will get cancelled. X1 will be equal to x2. Okay. Then what about the range? Y is equal to, sorry, onto function. Y is equal to 3 minus 4x. X will be equal to 3 minus y by 4. Right. So for every real number that you substitute here, are you getting a real number? Yes. So how to find that is, you know, I'll just give you another hint, okay? See if at all you're not able to see. I just wanted to extend this concept. This part is clear. Please confirm. When you substitute the value of y as a real number, you're getting a real number. That is one way. Check the domain of this function. So you know how to check the domain of a rational function? See, for example, if I have x divided by 2 minus 3x, for example, I have a rational function like this. 2 minus 3x should not be equal to, so x should not be equal to 2 by 3. So what will be the value you'll write? So you'll write r minus of 2 by 3. Am I right? So using the same logic, if this value had it been in the denominator, you need to apply that logic. But whereas if this value, like you have the function, right, in the numerator itself, sorry, the expression in the numerator itself, then it will take r values. Because we didn't speak anything about this x, did we? We spoke only about one thing. What is it? The denominator should not be 0. So find those values that give you the answer. Why I'm telling is, suppose had the question been like this, and when you're solving, right, you get x is equal to 4 divided by 3 minus y. Will it be an onto function? Why? Because what is the codomain set? Real number, but which element from the codomain set will not have a p-image? 0 kadayadu. 3 will not have. Because 3 minus y should not be equal to 0. Y should not be equal to 3, meaning r minus 3. The meaning of it is, whatever real number you keep plugging into it, you will get all the real numbers except 3. So the codomain is not exhausted. Hence, it will not be an onto function. Are you able to understand the difference? It's a minor point, but concentrate on it. Yes, sir. That's a general example. It's an example. I just taught you how. So this has nothing to do with this problem. I told how to find the domain of it. Am I clear? Please make a note of it. That's all. You solve this exercise, sir. Don't wait for me. You keep doing it. So those who have completed, keep doing it. Shall I proceed? We have another problem on this, no? This one. F is a function map from real number to real number. F of x is equal to 1 plus x square. Is this a 1-1 function? No. See, mostly if you see a quadratic function, right, or a quadratic polynomial, it will not be a 1-1 function because it takes the shape of a parabola. It will either take the shape of an upward parabola or a downward parabola. What shape will it take here? Why? Coefficient of x square is positive. If I ask you to draw the graph, how is it going to look like? So f is a function mapped from, let's say, r to r, and f of x is equal to 1 plus x square. Suppose I say like this, then how is the graph going to be? 1 unit to the left of origin. One unit above the origin, because y value is the one which is getting shifted. Simple, right? What graph is this? Y is equal to x square. To this y is equal to x square, if you add a 1, in which direction will the graph get shifted? It will be like this. So this will be the graph for y is equal to 1 plus x square or x square plus 1, whatever you write. Right? So if you do a horizontal line test also, it is failing. I hope everybody knows how to solve it using the steps. What are the steps you are going to follow? x1 comma x2 belongs to R. 1 plus x1 square is equal to 1 plus x2 square. 1 and 1 are gone. x1 will be equal to plus or minus x2. So then what about an onto function? Obviously, look at the graph, it's saying it's not onto. Why? Because from the codomain set, which numbers will not have a pre-image? Is it only negative? So you will not have values from minus infinity to minus 1 open. So not 1, minus 1, plus 1. From minus infinity to this value, what is this value? 0, 1. So y values are the codomain set values. So from minus infinity to 1, there are no pre-images. Right? But if you have to write it in the theoretical format, how will you do it? You will put y is equal to 1 plus x square, then x square will be equal to 1 minus y, then x will be equal to plus or minus root of 1 minus y. Now, how do you find the domain? How do you find the values of y in this? Y minus 1, oh sorry, okay, y minus 1. Then how will you find the domain of this? Like, how will you find the values of y? So anything that is under a square root, there are two cases. Anything under a square root which is in the numerator, anything under a square root which is in the denominator. So anything under a square root in the numerator will be like this: y minus 1 greater than or equal to 0. Had the same value been in the denominator, y minus 1 is strictly greater than 0. Then y will be greater than or equal to 1. What is the meaning of this? Whatever is the value of x you keep plugging in, the least value of y that will get generated is 1. So the values below it are ignored. Right? So both are clear, no? Right, please make a note of it. A. X1 and X2 come from the set A. Y1 and Y2 come from the set B. So which problem is this? Shall I proceed?
Yes, sir.
So how to do this? So there are two sets A and B. So look at the way the function is defined. The function is defined from A cross B to B cross A, and f of A comma B is equal to B comma A. Prove that this is bijective. Means it's supposed to be 1, 1 and onto. So how will you prove it? Right. I'll do one thing. I want you to first master these problems. By the end of this class, remind me I'm doing that problem. Okay. So before that, you master all these problems. F is a function mapped from natural number to natural number. F of n is equal to n plus 1 by 2 if n is odd, n by 2 if n is even. State whether the function f is bijective or not. So yesterday we did a similar kind of a problem. X plus 1 and x minus 1. You're done with this. You finished inverse? Try then. Yeah, this is your class notes or rough note. Why are you writing in reverse? One side physics, one side math. Your phone, your phone. Okay. It's not a 1-1. No? Why? If see f of n is equal to n by 2, you'll use that function only if the value of n is even. Instead of n, take x so that you'll understand. F of n, take it as f of x and try to solve the problem. It's minute 1. Is it so? For example, can you tell me what are the two values, two inputs which are generating the same output? Okay, see, if it is confusing, no, I would suggest you take it as f of x and it's not bijective. Okay, you give me the logic of why it is not. Huh? Okay, so from the natural number set to natural number set, you take 1, 2, 3, 4, for example. So when you plug in 1, which function should you consider? You will consider the first one because that is the one which is odd. Okay. 1. So 1 is mapped to 1. Okay. When you take an even number, you need to use the second function, right? So 2 by 2 will also get mapped to 1. It's not a 1-1 function. Since it's failing to be 1-1, it's not by 2. Okay. Here, why do we need to do that? Then you have to do it separately. I understood. You will get x1 is equal to x2. Both are same numbers, x2. But there, what you will get is, actually, you cannot do it like that. Here, it will not work because it's not a single function. That will work mostly for a single function. Here, it is split into 2 parts. You should take the numbers and then solve it. See, we generally take numbers and do it because the function is split into 2 parts. Single function, we can use that one. So this is the one you asked, right, Vaishnavi? Okay. So what about this? So there are two sets A and B. A is a set that is mapped from that has real number except 3. B is a set which has real number except 1. Okay. Consider the function A mapped from A to B defined by f of x is equal to x minus 2 by x minus 3. Is f a 1-1 and on to justify our answer. You're getting it as 1. Okay. How to solve this? Same steps. Take that x1, x2 belongs to r minus 3. Same steps. Thing is, you have to cross multiply and do. One side you will get x1 minus 2 by x1 minus 3. You will get the other side as x2 minus 1 by, x2 minus 2 by x2 minus 3. Cross multiply, do them. It will slightly be big. x1, x2, all those things will get cancelled. Check the answer. Are you able to understand what I'm trying to say? I'm saying the steps are there. No, follow that. So x1 comma x2 belongs to which set? The real number set except 3 means I am allowed to substitute any real number except 3. Because what kind of function is this? It's a rational function where it can q of x cannot be 0. So here, f of x1 na x1 minus 2 by x1 minus 3 is equal to x1 is equal to x2. Okay. x2 minus 2 by x2 minus 3. Cross multiply, do them. So when you multiply both, you will get x1, x2 minus 2x2 minus 3x1 plus 6 is equal to x1, x2 minus 2x1 minus 3x2 plus 6. Right, x1, x2 is gone. What else gets cancelled? 6 is gone. Then how did you say x1 is equal to x2? Which values will you take? You want to take this to the left. So 2 into x1 minus x2. Correct, Nada? 2 into x1 minus x2 minus 3 into x1 minus x2 is equal to 0. Correct? Did you understand what I did? I took this 2x1 to the left hand side, 2x1 to 2x2, 2 is common. I didn't multiply it. I took the common number out. How will you do it? Direct eliminate பண்ணுவ. Okay. Sorry, wait. I'll just tell me the steps. I'll write it. What are you telling me? You're saying 2x1 minus 2x2 is equal to. Oh, you're saying take 3x1 to. Okay. Sorry. Yeah. I got it. So you're saying you take this minus 3x1 to the other side and 3x2 to this side. It will directly get added. Okay, that is also there. I just took the 2 common and then did it. Is this step clear? Yeah. Same though. Minus of x1 minus x2 is 0. x1 is equal to x2, or this is also fine. We'll go with this. Right? x1 is equal to x2. Hence, it's a 1-1 function. Then what about an onto? Onto then it is challenging here. You will get that only. I'll do and show. See. What is the function y is equal to x minus? Okay, you need to write x in terms of y. What will you do? xy minus 3y is equal to x minus 2. Right? I need the x on the other side. I'll take the y to the other side. So x into y minus 1 is equal to 3y minus 2. Am I right? Just check it. xy minus function correct then? So xy minus 3y is equal to x minus 2. So x into y minus 1 is equal to 3y minus 2. Then what is the value of x? 3y minus 2 divided by y minus 1. So what are the values of y that you can substitute here so that you will have a real number coming out? I told you, this is the one I told you there. When you have a rational function, what is that you are supposed to consider? You can substitute any, you can substitute any real number except, what is the codomain set? Illian, r minus 1, so codomain is equal to range. Codomain is equal to range, it's an onto function. So next one. Answer. How many problems are there? 17. We are almost about to complete, no? Yeah. F is a function map from R to R defined by f of x is equal to x power 4. Choose the correct answer. It's very simple. Edra? D. Correct. Correct. So it's very simple. Whenever you have the power of x as an even number, it will not be 1, 1. Because it will be symmetric with respect to y-axis. So whether you have x square, x power 4, x power 6, whatever it is, it will be symmetric with respect to y-axis. Hence, it will not be a 1, 1 function at all. Then what about onto? It will not be onto also, provided the function is defined from R to R. It will not be onto because what are the codomain set consists? Codomain means y values. Codomain consists all the real numbers. But what does the range consist of? Range consists of 0 to infinity. And a 0, in substitute panel, you will get the least value is 0 only. No, you will get only positive values. So 0 to infinity. So the negative real numbers do not have a pre-image. You're right. So is that the logic you use, or you used any other method? You went with the method, steps were your same logic. That's good. So again, if you see the steps, no, it is the same old steps. Instead of x1, x2, they took it as x comma y. Right? X power 4 is equal to y power 4, x is equal to plus or minus y, hence it's not 1, 1. What about onto? You clearly know it. Since negative real numbers do not have a pre-image. Let's not see, you need not complicate this much and write it. You're able to prove that codomain is equal to range, it is onto. If not, it is not onto. What about this one? F of x is equal to 3x. Choose the correct answer. It's both 1, 1 and onto. It has an inverse existing. Why is it 1, 1? Because see, by now you should have got the steps. You will take x1 comma x2 belongs to R. So f of x1 is 3x1. 3x1 is equal to 3x2. 3, 3 get cancelled. Done. So similarly, y is equal to 3x. X will be equal to y by 3. Y is in the numerator. Since it's in the numerator, it will take any real number. Only if it is in the denominator, it is headache. Okay, this is about the composite function. So that 8th problem we are supposed to do, no? Yeah, tell me how to do this. So because there is a generic one, right? So A and B are two sets. Show that the function map from A cross B to B cross A. So A cross B consists of set of ordered pairs. B cross A consists of a set of ordered pairs. Right? So how do you prove that it's a 1, 1 function? Only difference is instead of x1 comma x2, you will take a1 comma b1 and a2 comma b2, because look at the independent variable, no? a1 comma b1 and a2 comma b2 belong to which set? Where do they come from? B. They come from the input set A cross B. Hey, these guys are there or not? These were by mark. Are you there? Those are online.
Yes, sir. Yes, sir.
Yes, sir.
Good. Right. So for it to be 1, 1, what are we supposed to do? F of A1 comma B1 is equal to F of A2 comma B2. Am I clear with this? This is an assumption. But what is F of A1 comma B1 according to the definition? When you substitute F of A comma B, how is the output coming as? B comma A. So what should I write it here as? B1 comma A1. Then what should I write the value here as? B2 comma A2. So if two ordered pairs are equal, then the first elements are equal and the second elements are equal. So what can I conclude? B1 is equal to B2 and A1 is equal to A2. From this, what can I conclude? This one. Since B1 and B2 are same, A1 and A2 are same, can I conclude that A1 comma B1, because this is the one I need to prove. Here the x1, x2. So A1 comma B1 is equal to A2 comma B2. Hence, it's a 1, 1 function. Makes sense? right? Please make a note of it. Fourth exercise is not there. Wait. Fourth exercise is not there in this chapter. It's always deleted. Let me check the. Did you get the 2023-24 syllabus?
Yes, sir.
1 minute. Let me check it. Last year they removed 1.3 also, but even if this year they removed, now I'm going to teach. Adilama, they deleted. 1.4 இல்லையா? ஓ எடுத்துட்டாங்களா? ஓகே நான் பார்க்கல. 1. Okay, it's a new version. Okay. Just give me a minute. I'll confirm it once. Right. How will you prove that it's a bijective? What number of elements are seen? So for this problem, right, unlike the other problems, we cannot say that this codomain is equal to range. So this time alone, I want you to go back and revisit the definition of onto function. What is it mathematically saying? I think they have deleted 1.3 also, but 1.3 has to be taught. As I told you, you will understand inverse function. Okay. So did you revisit, go to your textbook? What are they saying is the condition for the function to be an onto function? Okay, that is there, but what is the mathematical condition? You'll have f of x is equal to something. You have f of x is equal to y is there, no? That is the thing you need to use it. So this is x and this is y. So you can directly look at it and tell. So what are you saying? For all the inputs that come from A cross B, right, we have the elements which belong to B cross A, right? Or I can put it in the other way also. For every element that belongs to B cross A, there is a pre-image existing in the A cross B, because here it is directly understood that f of x is equal to y. Because the numbers are just swapped. Are you able to understand? Hence, it is an onto function also. Okay, officially according to 2023-24 syllabus, we are done with this chapter. But according to me, we are not done. Third exercise, because it is applicable in two places. What are the names? After 1.2, what is the name? You are able to see the headings. Composition and inverse of function. So composition of functions will come in differentiation also. There you need to know. Chain rule, everybody knows what is chain rule, right? So chain rule is basically function within a function, which is composition of function. Other than the concept. Second is inverse of a function. How to find the inverse. Maybe I'll not go in depth, but I'll teach you how to find them, and then we can go to the inverse trigonometry part also. So inverse trigonometry also, they have deleted 2.2. I don't know why they do it. It is very simple. I don't. But without that, you can't touch calculus. So that will maximum take one more class for me to teach. So according to the syllabus, let's not waste time. So what I'll do is for composition of functions and inverse of functions, I'll pre-record and send it. Go through it. Next class, we'll do around 3 to 4 problems based on it. Once you get a grip of it, we can go to the inverse trigonometric functions. Am I clear with it?
Yes, sir.
So till here, with the way you answered, I'm assuming you guys have understood, right? You need some more practice. I'll give you few more problems for this week. Do it sincerely, right? By Monday, make sure you're done with this relations and functions. Inverse trigonometry onwards. One more thing that is needed is maybe the formulae that you have learned last year, that sin C plus sin D and all those things are there. Just revise them. And so wherever it is there, we'll apply it. Yeah. So it's simple. Okay. So I'll see you all on Monday. Yes. Why is it on to? See, if a function is defined from set A to set B, you can call it as an onto function if f of x is equal to y. Okay. So in this case, the function is directly defined already. It's already defined. F of x is equal to y. You're able to see it for the elements that are mapped from A cross B to B cross A. It's a self-explanatory thing. Since it's already like f of x is equal to y, it is considered as 1. So the only challenge is we need to prove it for the 1-1 function. So 1-1, I hope you understood. Are you clear, right? Okay. Once you do that, since you'll write that f of x is equal to y, you're done. Since it's satisfying both, it's a bijective function. Okay. Yeah.
Thank you, sir.
Yeah. Yeah.
Thank you, sir.
Yeah. Thank you, guys.
Thank you, sir.
Yeah. Kalpagesh and Hariragha.
Thank you, sir.
Yeah.